Okay, looks like we are starting with memory, which I'm not excited about. Looks like we have to start with circular dependency. Man, for some reason, when you start looping wires back on each other, it gets me so confused. But we'll see how this goes. In our education system, we traditionally teach by tricking students into doing the wrong thing and then teasing them. I am not sure it benefits the students, but the teachers love it. Yeah, makes sense. Create a circular dependency. This is a circuit where the input of a component relies on its own output. In a circular dependency situation, it is not possible to determine the output of a component because you would first need to determine the input, which relies on the output, and so on, hence the circular. Yeah, so I think you can understand why I always get confused by this stuff. Test 1. Make a circuit where the input of a component depends on its own output. I mean, can you just do this? But I mean, I did it, right? I think it's kind of yelling at me, but I think I got it. Okay, now I need two components. Yes. I guess that's not what they want. All right, let's just do it like that then. Okay. I mean, that works. It yells at you, but it works. So I think we did it. Delayed lines. This level introduces the delay line component. It takes its input and outputs it one tick later. Construct a circuit that outputs the same as the input, just delayed by 2 ticks. So do we just put 2 of these together? Like that? No. Oh, I probably have to hook it up too. I mean, that would probably be... Yeah, okay. Just gotta hook up the wires. Odd ticks. Didn't we already have odd ticks? Am I going crazy? I thought we had one that was maybe odd number of signals. Yeah, okay. In the previous level, you learned how we don't allow circular dependencies. Now you must learn the one exception. The delay line is allowed to depend on its own input. This is because the input does not influence the rest of the circuit until the next tick. Square pins in the game never affect the output in the same tick. They therefore never cause circular dependencies. Okay. Output red on the even ticks and green on the odd ticks. Oh, do I have to do something like this? Oh, I have to have it that way? Okay, I think I've almost got it. Now I just need to negate the output. I think that should be fine. Yeah, there we go. Okay, I can probably replace with it. I think I was on the right track. So I was actually on the right track with an and here. I don't know why I switched it for an and, but yeah, that works too. Bit inverter. We are experimenting with how backgrounds influence cognitive functions in Earthlings. When invert is green, output the opposite value. Otherwise, just output value as is. Alright, so value and invert. Desired output. Desired output is XOR? I don't understand value and invert exactly. Okay. So, despite the funny background, you figured out this was just the XOR gate and just got okay. I'm glad I figured that out. That was a little bit confusing. Okay. All right, so far memory has not been that bad. Okay, I'm pleasantly surprised. Input selector. Even though he did not pass our test, we decided to keep the dog. Unlike most Earthlings, he is fluffy and follows simple instructions well. When the bit selector input is read, output byte A, otherwise output byte B. Okay, so this is just a multiplexer? Is that what they're trying to have me build? So, can we just... I wonder if we can use this. Switch. Let's see. So we need to have these, right? Maybe not, actually. Maybe we don't have to have those. We just have to have a switch. And then we just have to have another switch. Doing the same thing, but I guess inverted? Do I have these backwards? Oh, also, that's not hooked up. Okay, yeah, that's easy. Couple switches. Yeah, that's just a multiplexer, essentially. The bus and saving gracefully. This level has 2 byte inputs and 2 byte outputs. Your goal is to copy from one of the inputs to one of the outputs. The first bit input determines which input you should copy from. The second bit input determines which output you should copy to. Okay, so this is like a multiplexer and a demultiplexer, right? And all we have to use is the negate and the switch. There we go. Yeah. So I just had them backwards. So we got a multiplexer and a demultiplexer here. Saving gracefully. The delay line only allows us to save a value for one tick, but sometimes a component that can save a value for longer periods of time is useful. We want to build such a component. In the second level, you have 2 inputs. When the first input is green, update the saved value. The second input is the value. Always output what is currently saved. This is the diagram component we want you to build. All right, so this is a data latch, is what this is called. How do I build a data latch? I have to remember that. Oh, they give you delay line? Is that like a hint that that's supposed to be here? I want to say this is going to be like what we did before. We have to somehow loop. Yeah, okay. I for some reason it just clicked. If it's on, then we want to take the input here. If it's off, so if like it's negated, then we want to take the last input and refeed it back. Okay, I get it. I don't know why that took so long to click for me. But like I said, the memory stuff has always been kind of tough for me. Saving bytes. I'm assuming it's hopefully the same as the last one, just with bytes instead of a bit. Okay, yeah, it looks like the same as the last one, except with bytes instead. Okay, so I have this, which I feel like should be working. You can load a value, but if you save it, it'll automatically switch to 0. Like, these aren't outputting the way I thought they should be outputting, these 1-bit memories. So I must be doing something wrong. It is like if I have save enabled, you know, if I hit load, it doesn't change. So that's working right. But like this isn't outputting the right number. It's always outputting 0 for some reason. And I can't figure out why these aren't turning on. I just feel like this should work, but I don't know why it's not. Let me try getting rid of this. And this should go in here. What? Why is that? Why is that working now? I don't understand why that works, and the thing I had before doesn't. But okay, we're just gonna go with it. We made an 8-bit register. That's fine. That's all we need. Okay, we have this 1-bit decoder that opened up on the arithmetic side, but let's just continue with memory. Onto the counter. Counting is so fundamental, even insects do it. Make a device that counts increments once per tick. Build a counter that will increase by 1 each tick. Additionally, there should be an option for overriding the counter with a given value. You are given 2 inputs, a bit and a byte. The bit input should toggle between counting and overriding the value of the byte. So this is like going to be our program counter, I think, is the idea here. All right, so I guess we should start by just getting the once per tick thing working. Okay, so we got the counter working apart, I'm pretty sure. Which took some trial and error, because I just never remember how these memory registers are supposed to work with like delaying the output, but that seems to work just fine. Now we've just got to get it so that when this is on, it'll choose this value here. And I think we have a multiplexer to do that. So we have select, which would just be here. We're going to have this number, and then we're going to rewire this to go here. And that should choose if that's on. Yep, it gets this one, and if it's off, it gets whatever's here. So I see. The multiplexer needs to go into the memory and not like that. Not have two separate memories, though the multiplexer actually needs to move the value into the memory instead of the way I have it here. And it looks like it's working. Yeah, that's the delay was screwing me up, but that should work. It looks kind of tangled in this area, but I don't know if there's a way around that. But there we go. We've got a multiplexer taking in this value here, saving it to memory, and then we're just like adding in a loop. There we go. Let's try it. Yeah. Okay, I think that's a good place to stop. We've gone as far into memory as we can. We're going to have to dip back into arithmetic to finish this up, and I think we finish with building an ALU. So I'll save that for the next time.